Some people say that artificial intelligence will lead to massive economic changes, either a booming economy in which people all around the world have access to goods and services that were recently only available to rich Westerners, or to massive unemployment, with most of the middle class falling behind and entering poverty while a minority get vast riches. In this lecture, I want to put these predictions into context in the history of economic growth. I'm not going to say very much about AI per se, just how economic growth has changed and what that might tell us about possibilities for the future. So let's look at the history of economic growth to understand some context for predictions about the future. So here is the total economic output of the world over the past 2 centuries. We can see that this has been growing quickly, especially in recent decades. This corresponds to massive reductions in poverty, particularly in China and other parts of East Asia. But in recent decades, there's been significant reduction in severe poverty in India and much of Africa as well. Now, a word about what this means. When you think about GDP, this is the gross domestic product, you probably think about things like corporations and stock markets and banks. While those are often involved, that is a misleading way to think about things. The actual measure is attempting to measure the value of the goods and services that are being provided, not the financial intermediaries, the dollars and banks and stocks and things like that. The figure here is listed with a dollar sign, but one thing you'll note, if you can see that small thing there, is that this is indicated in international dollars at 2017 prices. So by saying international dollars, they mean they are using the price that something costs in the United States to indicate how valuable it is, regardless of where it's produced. So housing, food, clothing, those are all going to be counted towards the amount of goods and services being produced at something like their US 2017 prices. So even if things were more expensive in the past or are more expensive in other places, that's not going to be a contributing factor. It's going to try to measure how much of given goods and services are being produced. Uh, Now, of course, there are technical difficulties with any such measure, but we should keep in mind it's goods and services being measured here, not dollars or currency or anything like that. Now, most of the charts that I'm going to show here come from the site Our World in Data. This is a really useful website that has good explanations of what all of their charts mean, and it has many data sources on not just economics, but many other things. Now, some people claim that Our World in Data is too optimistic in the way that they focus on the decline in poverty worldwide over the past several decades. But I think that they are really showing an important part of the world's story, and they're a good source of information, even if there is other information that you think they're missing. Okay, so now one thing to think about here is this massive increase in the goods and services that have been produced. You might think, well, maybe this is just people, there being more people, and they all have basically the same access to goods and services they used to. So here is the world's population over partly that same time. Also, this chart goes for 50 years into the future. Global population has not yet stabilized or started to decline, but we can actually tell based on birth rates over the past few decades that global population will stabilize and very likely start to decline within our lifetime. Uh, so you might think maybe the increase in goods and services just parallels the increase in population. But here is the chart when we look at total amount of goods and services produced divided by the population. So in the original chart, the total amount of goods and services produced went up by a factor of something like 150. And total population in this time went up by a factor of about 10. So this chart still increases. It's only by a factor of 15 or so. But think about that. That is a lot of increased access to goods and services. And notably, it still has roughly the same shape, this exponential growth. And one way to think about exponential growth is that it's representing an increase where it takes the same amount of time to double each time it increases. So even though it's accelerating in absolute terms, it's in the ratio of increase, it's staying about constant. And it's often very useful to display exponential growth on a chart where instead of equally spaced lines representing equal differences in production, equally spaced lines will represent equal multiples of production. So here's what we have when we do that. Each of these, the darker lines are close to doubling in total capacity. You can see that $2,000 per person is one line. $5,000 is a bit more than double that, and then $10,000 is double that. And that's why the 2,000 to 5,000 is a slightly bigger gap than 5,000 to 10,000. This is what we call a logarithmic chart, where any constant difference in height on the y-axis corresponds to a constant multiplication. And so this chart now shows global production of goods and services per person on a logarithmic chart over the past 200 years. And on this chart, we can see economic growth is roughly a straight line. Economic output per person doubles roughly every 50 to 60 years during this period. Gigantic worldwide events do show up as changes in this trajectory. You can see a bit of roughness in the middle of the chart when the Great Depression slowed down growth and the Second World War stopped global growth in productive services for a little while. The massive disruptions of the COVID pandemic and resulting sudden slowdown of global travel and trade show up right near the end as the only significant drop in this chart. And so this feels like how things have always been, not just within the memory of people who are now alive, but for many generations. Throughout the age of steam in the early 1800s, and then electrification and running water, and the revolutions of diesel and petroleum, and then the post-industrial economy, the service economy, the growth of computing and the internet. During this entire period, the overall growth rate in the value of goods and services produced per person has been roughly the same. So it feels like a reasonable default to assume that this same rate of exponential growth is the human default due to technological progress, as long as we keep developing new economic technologies at this same exponentially accelerating rate that we have been, right? Well, let's zoom out a little bit more. So this is that same chart, global production of goods and services per capita, but this time going back 1,000 years rather than 200 years. So if we flip back, here's the period from 1820 to 2022. It went from about $1,100 worth of goods and services in US 2017 dollars to something like 17,000 US dollars of worth of goods and services per person in 2022 at this constant exponential growth rate. And if we go back here, we see from 1820 to 2022, it does have that linear trend. But we see that the previous 800 years had a much slower growth rate. Obviously, the measures that we have of economic output, of what sorts of goods and services were being produced, are much sketchier when we go farther back, especially when you go far enough back that political systems around the world just paid much less attention to the goods and services that ordinary people were producing and consuming. The governments were just organized for the benefit of the nobility. And in much of that period, there were major parts of the world with few or no written records. But at the same time, we do know that throughout most of that period, the vast majority of people, nearly everywhere on Earth, were small-scale farmers. They would grow enough crops to feed themselves and their family, make their own clothing, mostly repair their own tools, but occasionally venture into town to trade for some things. If they had surplus, these small-scale farmers would often have larger families that they would then feed with the same amount of goods and services per person. So there was no longer any surplus. Or in some cases, they wouldn't increase their family size. Instead, this wealth would be taxed away by local nobles or spent on new kinds of products at a market town. And in a few cases where the surplus was able to be concentrated, these individual families would become local nobles of their own and start taxing away the surplus of others. And so, even though we don't have the records of most of the subsistence farms, we do often have records of the nobles or the townsfolk, and those records will be able to identify most of the per capita growth in goods and services. So this might not be exactly right for that long 800-year period, but we can be fairly confident that something like this is the amount of growth. There was not growth in goods and services anything like the following 200 years. And notably, uh, despite all the many massive events in world history during this period from 1000 to 1800 AD, there was the Afro-Eurasian plague epidemic in the 1300s that we call the Black Death in Europe, but affected large parts of the world. The Mongol conquests of Asia, which overthrew the ruling dynasties in China and India and replaced many other governments and destroyed many people. There was the European colonization of the Americas that completely upended political systems and created pandemics there. There were revolutions that overthrew governments and replaced dynasties and changed, even in the last couple centuries there, changing uh, feudal systems for something more like democratic systems. Even through all of this, there was only a small fraction of the population that lived in cities or that were nobles. The growth in the number of those people and the growth in their quality of life just was much slower than what happened starting in the 1800s. The Industrial Revolution really was a bigger change in the global trajectory of quality of life than anything that came in those centuries before. Now, the fact that this happened once, there was this major change in trajectory, means that it's not out of the question that it could happen again. If there is a transformation of the economy as big as the transition from the agricultural economy of the past several thousand years to the industrial economy in the past 2 centuries, could artificial intelligence provide that big of a change? Maybe, but it is worth noting that uh, this one transition from the agricultural economy to the industrial economy made a change in the trajectory, but the other transitions before then, or the transitions since then, from a coal-based economy to an economy based on petroleum and electricity, or the transition from an economy where most people were involved in manufacturing to one where most people are involved in the provision of services, don't seem to have changed this trajectory substantially. Now, some economists point out perhaps the transition from the manufacturing economy of the industrial period to the service economy of the post-industrial period has actually slowed down the growth rate in the wealthy countries of the world. Global growth has maintained its same exponential pattern because there are still many parts of the world where people are making the transition from agriculture to industry, as they did in China at the turn of the 21st century, and in Korea in the 1960s, and in Japan and Russia in the 1930s, and in Germany and the United States in the 1880s, and in Britain and France in the 1840s. This is still happening in many parts of the world, though perhaps there will be a global slowdown if all the world's population finally reaches the industrial or post-industrial economy. But there could also be an acceleration if artificial intelligence turns out to be the same sort of accelerator that the Industrial Revolution was. Is that plausible? Maybe. We'd have to think a lot more closely about artificial intelligence to see whether or not that is plausible. But one thing that's worth thinking about is let's think about why the Industrial Revolution actually led to this acceleration. And what we specifically know from this chart is there was a major transition in global economic growth rates 2 centuries ago. If there's another major transition, should we expect it to be another acceleration to an even faster growth rate or a sudden deceleration to the standard growth rate that existed for centuries before that, or possibly a drop? So why did the Industrial Revolution lead to an acceleration? Well, the core aspect of the Industrial Revolution was the revolution in energy use. And Here we have a graph of world energy use. And the light brown at the bottom that is mostly constant is the solar energy gathered by plants that are grown for human and animal consumption. The solar energy trapped in trees that is then harvested for wood that is burned for all the various things that people have been burning wood for thousands of years. And one thing that's interesting is that even though the Industrial Revolution was sparked by this growth in the use of coal, coal didn't actually catch up to traditional biomass until nearly a century into the Industrial Revolution. Notably, petroleum and natural gas don't even become really visible on this chart until several decades after they were already becoming economically important as well. So often there's some initial growth that is prompted by just the beginnings of this new energy source. And we can see in the decades since, a lot more energy sources have been added over the course of the 20th century. Now, one thing we know is much of this energy use will stop. We want to stop using coal, oil, and gas because of their climate impacts, but even if we don't stop for their climate impacts, they will at some point run out. And so if energy use is the core of global economic growth, then an energy transition where we lose these sources of most of the world's energy, even though the developed world has switched off of coal and oil and natural gas to a large extent, much of the world is still running on it. Uh, Perhaps a decrease in energy use might put just as sudden an end to the current exponential age as its sudden beginning. Now, the physicist Tom Murphy illustrates this very starkly with this graph. On this graph, he's showing the energy use uh, over the course of human history. And for thousands and thousands of years, it was barely noticeable on this chart. Then in the past 2 centuries, we have this sudden exponential increase with the fossil fuels. And over the next few centuries, that will stop. And either we will have some new energy source that makes up for that, or maybe even continues the growth, or we will be going back to the energy use of that past. And his blog has a lot of thinking about these sorts of hard limits to growth. And he tells another part of the story that our world in data does not. Now, one other thing that he shows, even if we make the transition from fossil fuels to some other sort of energy, he notes if energy use keeps increasing at the same exponential rate that it has been, here he just tracks what that looks like over the next several centuries. The green text there shows how far into the future corresponds to a certain distance into the past. So the Industrial Revolution is 200 years in the past. If we continue the same exponential growth rate, just a little bit longer than the time that it has been since the Industrial Revolution, we will be using as much energy worldwide as all the sunlight that hits the land. And if we continue the growth rate for even just another century more to 4 centuries out, we will be using as much energy as all the sunlight that hits anywhere on Earth. And now you might think, well, solar energy is only one of the alternative energy sources, right? Well, basically all renewable energy, wind, ocean currents, hydropower, biomass, all of this depends on incoming sunlight for its energy. So the amount of sunlight that comes in from solar energy is a hard cap on this kind of renewable energy. There's a few other possibilities like geothermal energy or nuclear energy. Uh, he gives some arguments for why those won't be as large as total solar energy. But he notes, even so, even if we manage to find other energy sources, at a certain point of continuing this growth rate, we'll hit as much energy as the sun produces. And that much energy on the surface of the Earth would vaporize everything. And so we will not continue energy growth that much. The question is, when will it stop? Will it be very soon so that these past 2 centuries were just an outlier, or will something else happen? So if energy use is the key to growth in goods and services, then these past 2 centuries, the time that we all are used to and all our politics is based around, must be an outlier. But now, is that true? So here's some charts from Our World in Data again. These charts show changes in GDP per capita and energy use per capita from 1995 to 2019 in several large countries. I've got some North American countries, the USA and Canada on the left, some European countries, Sweden and France in the middle, and some Asian countries, China and South Korea on the right. The purple line that generally keeps going up for all of them, though most of them have a drop in 2008 with the financial crisis, that purple line that keeps increasing is GDP per capita. How much goods and services the people in these countries produce and consume. The red and the blue lines represent the total energy use of these countries. Blue is the energy use actually occurring within the country, while red attempts to track the energy use for the goods and services that are consumed in the country. So we add in whatever energy was used to produce imports and subtract out whatever energy was used to produce exports. And so countries like the United States and France that tend to export less energy intensive goods and services like movies and music and financial services and import more energy intensive ones like manufactured goods, uh, the United States and France tend to have the red line above the blue line, while some countries like Canada and South Korea that export either petroleum or manufactured goods or things like that, and import less energy intensive goods, have the blue line above the red line. But regardless of whether we're tracking the blue line or the red line as energy use, what we can see is that in all of these countries, GDP has continued to grow over this period, even though energy use has stopped growing. In Asia, it seems to have stopped growing maybe around 2010. In North America, maybe around 1995. In Europe, energy use has actually been decreasing. And so if economic production of goods and services can manage to increase even though energy use is decreasing, maybe it's not inevitable that the energy transition means a stop to economic growth. So overall, to summarize, looking back at history, we see that the world has been on a remarkably stable exponential trajectory for the past 2 centuries, or about 10 generations. Despite major scientific, technological, political, social, and other transformations in this time, this exponential trend has continued roughly constantly. There are some blips like depressions and recessions and wars, but they haven't really changed the trend. This at first makes us think that this trend is inevitable and will continue. But looking further, 10 generations is really not much in the lifespan of humanity. Many people can trace their own ancestors back farther than that. It's out of the memory of anyone now alive, and it's outside the memory of most modern political systems, but this is not the deep mists of time. This is a period that we have adequate records of. So we know that there will be some major transitions in the world economy in coming decades. There will be an energy transition. The AI transition will be part of that. It may be that the AI transition increases energy consumption at a time when energy production is stagnating or falling. Or perhaps the AI transition will enable all sorts of other goods and services to be produced with less energy. Or maybe the AI transition will do something completely unexpected. But at any rate, there will be some transitions. The existence of the Industrial Revolution gives us some reason to think that a sufficiently significant transition in how goods and services are provided could result in either substantial further acceleration of growth or an end to that. Its basis in energy gives us some reason to think that this growth could stop, but the decoupling of various major developed economies from energy use and the potential decoupling of world energy use from world economic progress might defeat this concern. In the end, we definitely cannot be anything like certain about any of this. AI could conceivably lead to a major increase in growth like the Industrial Revolution, or it could coincide with the end of this blip of the past 2 centuries. Or maybe AI will be exactly what we need to maintain that same trend for another few decades. What history tells us is we absolutely should be open to the possibility that there will be major changes in how the economy works, far bigger than anything that's happened in the lifetime of anyone now alive, or even anyone alive at the time that the oldest person now alive was born. But 2 centuries is still almost nothing in the history of humanity. There could be major changes, we just don't know.